I'll give you about 2 more minutes to do these 2 problems, and then we'll go over them. Okay, I think we can get started on these. You see somebody's already sent me the answers, so that means that he had enough time. Things look good. We'll take a look at them and talk about them. Thank you, Tashana. Okay. We're looking at, now, all I gave you in the instructions in each of these is to factor. So, and if you recall from Tuesday, I talked about 4 types of factoring that we do. We do what we call a common factor. We do grouping. We do difference of squares. And we do trinomial factoring. And I said what you're going to have to do, sometimes they'll tell you factor by grouping, or sometimes they'll say use a difference of squares. But even if those instructions are not given, you should know how to proceed. So if we look at this first one, in every single instance, the first thing I look for is there a common factor? And if you notice, there is no common factor. Common factor, if there are 4 terms, it would have to be able to go into every single one of the 4 terms. So there's no common factor here. So the next thing we look at, how many terms does it have? And when it has 4 terms, then we know that the only way we can go ahead with this is to see if we could possibly factor by what's called grouping. Are there other ways to factor 4-term things? Yes, but that's beyond the scope of this course. If you're given something that has 4 terms and you're asked to factor it, it means that you want to try and do it using grouping, which means you take your first 2 terms and look if there's a common factor in those first 2 terms. So the first 2 terms are t to the 3 minus 3t squared. So this one has a coefficient of 1, so there is no common number, but there is a common letter. They both have t's, and that means that the common factor here has to be the one with the lower exponent, which is the t squared. So I'm going to put t squared out and divide the t squared into t cubed. Remember, we're subtracting exponents. 3 minus 2 is 1, so that becomes t. And here, the t squared cancels out with the t squared, and all you're left with is the -3. So that takes care of your first group. You then look at your second group, your second 2 numbers, and you look, is there a common factor in that group? And always look at the sign of that first term of that group. If it's positive, your common factor is going to be positive. If it's negative, you're going to use a common factor that's negative. So this is positive, and I notice that 4 goes into both of them, so we have a common factor of 4, and 4 into 4t gives me t, and 4 into -12 gives me -3. And now what I see is I have a common binomial factor. The t minus 3 is a factor of both, so I'm going to put it in front. And in the second parentheses, I put whatever I have on the outside, which is the t squared plus 4. Before I say that I'm completed with that, I look at each parentheses. Now, I know I can't factor t minus 3 any further. There's nothing else to simplify it. So I look at the t squared plus 4. Since it has a t squared, it might be able to be broken down further, except since it's two terms, the only way it could be factored would be if we had the difference of the squares. If we would have had here t squared minus 4, we could have broken it down further. But t squared plus 4 cannot be factored further. So this is the correct answer. Yes, that was the answer that was sent to me. Perfect. Okay, let's go to the next one. Again, step 1, always look for a common factor. Well, there's 16 and 81. Nothing goes into both 16 and 81, except of course 1. That's not what we're looking for. So then we look. How many terms do we have? 2. If there are 2 terms, the only way we could possibly factor would be if we have the difference of squares. So I have to look, is the first term a perfect square? And it is. 16x squared is 4x times 4x. Is the second term a perfect square? 81 is 9 times 9. And is there a minus in between them? That makes it the difference of squares. So right away I can put it into 2 parentheses. I take the square root of each, 4x and 4x, and 9 and 9. And in one parentheses, I put a plus, and one parentheses, I put a minus. In other words, our answer are what we call conjugate binomials. 2 binomials that are identical, except one has a plus and one has a minus. Those are the only type of binomials that when you multiply them, you end up not with a trinomial, but with a binomial. Okay. So now let's continue from here. First of all, I want to mention, if you notice, your email that the math department has scheduled the midterm to be the week of October 18th. In other words, not next week, but the week after. And the specific, I have to find out if I can give it to you to take outside of class or whether we have to do it as an in-class. If it's in class, then it'll be 2 weeks from today on the Thursday. Otherwise, if I can assign it for out of class, then I'll give you other options. But the midterm is not in Delta Math. The midterm is going to be on Blackboard. It's going to be a multiple choice test on Blackboard. By next week, I will send you a practice midterm. If you do well, I'll count it as a test mark. If you don't do well, or if you do better on your midterm than you do on the practice midterm, then I will count the midterm mark as the second test mark as well. Okay, so our second test is coming up. It's going to be on Blackboard. It's going to be a preview of the midterm. I will, as soon as I receive it from the department, I will post it for you. So then I'll give you the dates when you can hand it in. You do it right on Blackboard. And again, if it is going to be considered a test, but if you do better on the midterm than you did on the practice midterm, I will count as your test mark, the mark you get on the midterm. So our second test will be coming up. And then our midterm is coming up the following week. Again, I sent this in an email, so yes. When are you posting the grades? I don't, you grade it for, first of all, for Delta Math, the grade is right on your Delta Math account. That's why I haven't separately posted it. When, after this first test, which will be next week, of course, then I will post the marks for you. And after the midterm, I will then send each person an individual email with an approximation of where they stand at this point in the term. That I'll do shortly after the midterm so that you'll have an idea of whether you're in the A, the B, the C range. Actually, the lowest, I don't think I'm going to give anybody a mark lower than a C. If you're passing, you will get at least a C so that you don't have to retake the course. Any other questions? Okay, but further on in the term, you will see on Blackboard things entered for your grades. It just didn't seem necessary at this point because we've only had that one test on Delta Math. Okay, so I want to go on with what we were talking about at the end of Tuesday, and that's what's called factoring of trinomials. We're going to talk about factoring trinomials, and then we're going to talk about what is the purpose of being able to factor, how does it help us, where do we use it, etc. So let's take, just as a reminder, something like this. A squared minus 8a minus 9. Let's say I wanted to factor this. This is a trinomial. The leading coefficient, the number in front of the square term, is 1. And the last term is -9. So together, my AC, remember this is called the AC method. The first times the last is -9. Okay, we know that AC equals -9. We also know that B, which is a number in front of the linear term, I won't call it in front of the X term, but the one that doesn't have an exponent, is -8. So we have AC being -9 and B equaling -8. And our approach is to always find two numbers that multiply to AC and also combine or add to B. That's how the AC method works. So in this case, we're looking for two numbers that when we multiply them, they're going to give me -9. And when I combine them together, they're going to give me -8. Now, first thing I know is that one is going to be positive and one's going to be negative, because the only way you can get a product that's negative is if you have one side being positive, one being negative. So let's think of the possibilities of numbers that multiply to -9. So it could be 9 and 1, and it could be 3 and 3. And that's basically it. Now, except that it could also have been 1 and 9. Let's think about it. When I multiply positive 1 times positive 9 times negative 1, I get negative 9. But when I combine positive 9 and negative 1, I get positive 8. Now, I didn't want positive 8. I wanted negative 8. Usually when I get the right number, but the sign is wrong, it just means switch the signs. Make the 1 the positive and the 9 the negative. Notice if you multiply a positive 1 with a negative 9, you will certainly get negative 9. And when you add positive 1 with negative 9, you're going to get negative 8. That's the combination we wanted. We wanted to multiply the AC and add. I said combine because you really have to consider, it looks like you're subtracting, but that's because the operation of addition when the signs are opposite is really involves subtracting the numbers. So that's why I use the term combine. Combining +1 and negative 9 gives you negative 8. Once you have that, you rewrite your trinomial into a 4-term expression. You leave the first term alone, the a squared. You leave the last term alone, the negative 9. But the middle term, the negative a, you replace by 1a and negative 9a. And it doesn't matter if you put the 1a, the positive 1a first and the negative 9a second or vice versa. It will be completely right whichever way you do it. Notice you just put the letter next to each one of these numbers, and notice when you combine 1a and negative 9a, that is a negative 8a. So why do we break this down? Why do we make it into 4 terms when it was just 3 terms? Because now we can use grouping. If you think about it, in our first group, we have a common factor of a. So this becomes a times a plus 1. In my second group, I have a common factor of 9, and it actually is a negative 9 because the leading coefficient here of that second group is negative. So negative 9 is our common factor. And when I divide negative 9 into negative 9a, I get a. And when I divide negative 9 into negative 9, it becomes positive 1. And then I can finish the factoring by doing a plus 1 in front, our common binomial factor. And then our second parentheses, we put the a minus 9. And we have factored this a squared minus 8a minus 9 into 2 binomials. Now, I know this looks like it takes a long time. It only takes a long time in the beginning. You don't have to, once you do it a bunch of times, you'll see that it really works quite quickly. Let's try another example. Okay, I'm doing this example here. 9x squared plus 15x plus 4. Let's see if we can factor this example. I'm going to do like 1 or 2 more, and then I'm going to give you a couple to try on your own. Okay, again, we have a trinomial. Step 1, look for a common factor. Is there any number that goes into all three of these, 9, 15, and 4? I can't think of any. And if I look at the letters, this has an x squared and this has an x, but there's no x over here. No common factor. Again, that's always my first step. Next, I figure out what AC is. Remember, AC is the very first number times the very last number, and don't forget to include the signs. If it's just a plain x squared, that first number is a 1. If the leading coefficient is 1, you're not going to see 1x squared, but you'll know it's 1. So if I take AC 4 times 9, I get 36.
Is that a plus 15x or a minus 15x?
I'm sorry?
Oh, it's a plus. Okay, I couldn't see for a second.
These are all these are both pluses.
Okay.
Should I write bigger? Is that going to make it better?
No, it's good.
Okay, thanks. Okay, so when we did AC, we got positive 36. And my B, remember that's the middle number, is 15, the positive 15. So let's think about it. We're looking for two numbers that are going to multiply to 36. And when we add them or when we combine them, we're going to get 15. So let's talk about, I always like to think about the signs first. Since this is positive, the only way you can get a positive product is if both signs are the same. Either both signs are positive or both signs are negative. But since this B happens to be positive, it must mean that both signs are positive, because there's no way I can add two negatives and get a positive. So I know that my signs are, this is going to be easy. They're both going to be pluses. Okay, let's think what multiplies to 36. I'm going to go through a whole list. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. I think that takes care of, there are a lot of numbers that when you multiply them will give you 36. So now that takes care of the first thing. They're both going to be positive and they could be these combinations. So let's pick out the combination that gives me 15. And obviously, when I add the 12 and the 3, that's when I get 15. So it must be that I want to break this 9x squared. Here, I'm putting the 4 over here. The 15x of that, I want to break it up into 3x and 12x. Notice all I've done in this AC method is want to go back from 3 terms, because these are really like terms. I want to go back to the 4 terms that it really originally was when you were doing the FOIL, the first, outer, inner, last. And again, now we do our grouping method. The 9x squared plus 3x has a common factor of 3x, because 3 goes into 9 and 3. And 3x into 9x squared gives me 3x. And 3x into 3x, everything cancels out, so it leaves a 1. Now we go to our second group. We have 12x plus 4. This is positive, so my common factor is going to be positive. And it's going to be 4 because 4 goes into both of them. 4 into 12x is 3x. And 4 into 4 goes 1. Don't forget to put in that 1. If everything factor cancels out, your answer has to be 1. You're not losing it. When you divide something by itself, you get 1. And now my final step is to take the common parentheses, the common binomial, 3x plus 1, put that in one parentheses, and what goes in the second parentheses is 3x plus 4. You can always check if you've done this correctly by doing FOIL back and making sure you get this. Can we do, let's do one more, and then I'll give you a couple to try. Notice in this problem, our leading coefficient was not just plain 1. It wasn't just a plain x squared term. It was had a leading coefficient other than 1. Okay, so let's try this example. (12x to the third) minus 10x squared minus 12x. I want to factor this completely. We're always trying to factor what's called factor completely. And we, again, as we did before, the first thing we always look for is a common factor. Well, I have a 12, a 10, and a 12. There is a number that goes into all of those. It happens to be 2. And if I look at the variables, the letters, I have an x to the third, an x squared, and an x. They all have x's in them. And the one with the lowest exponent is just a plain x. So 2x happens to be my common factor. Again, step number 1, always look to see if you have a common factor. Okay, now let's factor out that common factor by dividing everything by the 2x. 2 into 12x cubed will give me 6x squared. 2x into negative 10x squared, so the 2 into the negative 10 is negative 5, and the x into the x squared gives me x. And finally, 2x into negative 12x, the 2 into the negative 12 gives me negative 6, and the x cancels out. So I'm left with a monomial on the outside, the common monomial factor, and a trinomial. Now, this is the trinomial I was left with. 6x squared minus 5x minus 6. That's what was left in the integral. Whenever I do something like this, I don't stop right here. I see, is it possible to go further? Is it possible to factor this any further than we did? And since this is a trinomial, I'm going to try doing it by the AC method. Okay, what is our AC? Our A is 6 and our C is negative 6. So 6 times negative 6, which gives me negative 36. And the B is the number in front of the X is negative 1. So we're going to see, it might not be possible, we're going to try and find two numbers that multiply to negative 36, but when I combine them, they're going to give me negative 5. Now, since the AC is negative, it means one of the numbers is going to be positive and one of the numbers is going to be negative. So let's just make a list of numbers that could possibly multiply to 36. And obviously 1 is 1 times 36. Now, if I were to combine the positive 1 and the negative 36, I would get negative 35. That's not anywhere near negative 5. So let's try going further. Another combination would be 2 and 18. But again, if I do a positive 2 and combine it with a negative 18, positive 2 and negative 18 gives me negative 16. We're getting closer, but we're not there yet. Okay, let's try 3. Then we'd have positive 3 and negative 12. But when I combine a +3 with a -12, I get -9. Still not working. So let's go to the next combination, which is 4 and 9. And notice when I combine +4 with -9, it does give me -5. So this is the right combination. Notice I'm putting in the signs. This is going to be a +4 and a -9. If, when you're doing this whole business, these are a little bit difficult numbers because the larger the numbers are, the more combinations you might get. If you come out with the right number, but the sign is wrong, it just means, let's say this would have been +4 and -9 gave us -5, and maybe this would have been a +5. I would have just switched the numbers. I would have put the 9 in the positive and the 4 in the negative. In other words, if the numbers aren't, if it's not giving me the right number, I just don't even use those numbers anymore. I just wait until I get the right combination. So I'm going to rewrite this 6x squared minus 5x minus 6, leaving the 6x squared alone and leaving the -6 alone, and rewriting the -5x as plus 4x and minus 9x. And now I have my 4 terms, so I can use grouping. In my first group, I have a common factor of 2x, because 2 goes into both of these numbers and x goes into both of them. And 2x into 6x squared gives me 3x. And 2x into 4x, the x's cancel out, and I'm left with just 2. In the next group, my common factor, well, between the 9 and the 6, I can use 3, but since this is a -9, my common factor is going to be -3. And -3 into -9x is +3x, and -6 into -3 into -6 gives me +2. And my common binomial factor is the 3x plus 2, which I put in front. And in my second parentheses, I put the numbers that are on the outside, 2x minus 3. It would be perfectly all right to put the 2x minus 3 first and the 3x plus 2 first. Doesn't matter what order you put the parentheses, but don't mix up the signs. Don't make it 3x minus 2 and 2x plus 3. That would be wrong. The only thing can be is that the order of the 2 parentheses can be switched. Does anybody have any questions about this?
So at the end of the solution, you don't write the 2x? Is the 2x not? Because you had 2x, 3x plus 2 bracket minus 3. So the solution is only the what's in the bracket, the 3x.
Right, because if you would take this and use FOIL on this, you would end up getting right back to this. Oh, no, I'm sorry, you're right.
Yeah, the 2x is supposed to be at the end of the solution.
Reminded me. I forgot all about this. There was this 2x in the front, so my final answer would have been the 2x times the 3x plus 2 and the 2x minus
3. Yeah.
And don't do what I just did. That is a very common error. When you take out a common factor just to forget about it, in your final answer, you have to include it. This was just the inside part, but the final answer was the 2x that we had taken out originally, and the 3x plus 2 and the 2x minus 3. Thank you so much for making that correction, because it would have been a major mistake. Okay, are you ready to try on your own? I'm going to give you 2 problems to try. And while you're doing those 2 problems, I will take attendance. Okay, here's problem number 1. Four x to the third minus 16x squared minus 20x. Okay, I'll read it again. 4x to the third minus 16x squared minus 20x. That's your first problem. And the second problem is going to be six y squared minus 7y plus 2. Jesus Antonio. Jackson Avila. Good morning. Tiffany. Tiffany, you here? Kayla. Tashana. Good morning. Dion, I know you're here. Wensley. Wensley. Tatiana. Good morning. Awa Diallo. Good morning. Ashay. Eliana. Eliana. Christopher. Emily. Anastasia. Zenabu. Ismail.
Here.
Hi. I'm beginning to think I'm talking only to myself. Thank you. Jaden. Ashiana. Anijah. Thomas. Thomas John.
I'm here.
Hi, good morning.
Good morning.
Paul.
Here.
Hi, good morning.
Morning.
Ashley.
I'm here.
Hi.
Good morning.
Angelica.
Here.
Hi, good morning.
Good morning.
Akeem, I know you're here because I think you came in first.
Did you say Akeem?
Tayon,
Here.
hi, good morning. Craig. Giovanni. Devonly.
Here.
Hi, good morning. And Najay Waddell. Okay, let me repeat. We are if you looked on your Blackboard account this morning, you see that I added a midterm review. Most of those problems I sent you already as part of the weekly folder, those exercises for each chapter. This midterm review I was just sent by the department, and basically it includes all the types of problems that you might see on the midterm. The midterm is scheduled for the week of October 18th. If we're going to do it specifically in class, I have to find out if that's a requirement. If we do, then it'll be on Thursday. If not, I will probably give you a post-it, let's say on Tuesday, and give you until the following Tuesday to complete it. But it's going to be the week of the 18th. Next week, there will be a test. It will be a pre-test of the midterm, and it'll be on Blackboard because the midterm and the final is also on Blackboard. So as practice, basically a practice test for the midterm. What I do with that mark is if it's a good mark, I keep it. If it turns out that the mark you get on the midterm is higher than the mark you got on this test, which is going to be test 2, you're going to look for it on Blackboard. Again, I will send you a notification when it's available. But if you do better on the actual midterm than the practice midterm, then I will take as your second test mark the midterm as well. So you'd have if you get, let's say, 90 on the midterm, then your second test will read 90 and your midterm will also read 90. If it turns out, let's say you get a 90 on the practice, but you only get an 80 on the midterm, I will then keep the 90 for the second test. I will not switch the mark of the midterm for. Okay. Tashana, you're on the ball. I see you've already gotten answers. Let's see if we can work on this together now. Okay, so let's look at the first example. The first example, again, what do we always look for first? No matter what kind of factoring you're asked to do, the first thing you always look for is a common factor. So let's look at this. The numbers, the coefficients are 4, 16, and 20. Obviously, 4 goes into all of those. And since it's starting, the leading coefficient is positive, we're going to use a positive number. So that'll be 4. Also, x cubed, x squared, and x, that each of the terms has an x in it. The one with the lowest exponent is 1, so 4x is our common factor. And when I divide out the 4x, I get 4x into 4x cubed, and it gives me x squared. And 4x into negative 16x is negative 4x. And 4x into negative 20, remember, don't forget, x into x cancels. 4 into negative 20 is negative 5. And I know my final answer has to have this 4x in front of it, but what we're going to do is we're going to try and factor this trinomial inside the parentheses further. And since it's a trinomial, we use the AC method. And the A in this case, remember, the 4x is, I'm not using it anymore. I'll just put it on as part of the answer at the end. It's the common factor. But what we're trying to factor further is x squared minus 4x minus 5. So my AC, remember the A here is 1. 1 times negative 5 is negative 5. And my B is negative 4. The number in front of the x. So, first of all, I see that AC is negative. Means one's number is going to be positive and one's going to be negative. And I need numbers that multiply to 5. So either it'll be a positive 5 and a negative 1, or it could be the 1 is positive and the 5 is the negative. So how will we know? Well, when I combine positive 5 and negative 1, I get plus 4. But I don't want plus 4, I want negative 4. So I know it has to be the positive 1 and the 5 has to be the negative. Because positive 1 and negative 5 do give me negative 4. So we're going to rewrite this now. X squared plus 1x minus 5x minus 5. Okay, and my common factor in the first group is x, so this becomes x plus 1. And my common factor in my second group is, well, it's the 5s, and since it starts with a negative, it's negative 5, and negative 5 into x, negative 5x is x, and negative 5 into negative 5 is plus 1. So there's our common binomial factor, the x plus 1. The second becomes the x minus 5. And don't forget the 4x. This would be your final answer. Is this what people got? Let's see. Good, excellent, excellent. I see a few answers like that. Okay, so now let's look at the second one. The 6y squared minus 7y plus 2. So again, let's look if there is a common factor. And there isn't, because this is 6, this is 7, 2, no number, and there's no y in all three terms, so there's no common factor. But again, I'm going to do my AC. My AC is going to be 6 times 2, which is 12. And my B is going to be negative 7. Now, I'm looking for two numbers that multiply to 12. And it has to be a positive 12. So either it's going to be two positives, or it's going to be two negatives, because positive times positive is positive, negative times negative is also positive. But since I need my numbers to combine to a negative number, it must be that both numbers are negative. Because if everything is positive, I'm never going to get a negative in there at all. Okay? So let's look. So we know what our signs are going to be. Let's look at numbers that multiply to 12. So it could be 12 times 1, 6 times 2, 4 times 3. I think that's basically it. And the ones that combine to -7 are obviously the 4 and the 3, the -4 and the -3. So I'm going to rewrite this as 6y squared minus 4y minus 3y plus 2. Notice the -4 and the -3 is the -7. And again, how I do my grouping, in my first group, between the 6 and the 4, I have a common factor of 2. Y squared and y is y, so that becomes 2y times 3y. 2 into -4 is -2. The y's cancel out. Now, if I look at my second group, I don't see any common factor at all. There's nothing that goes into both 3 and 2, and this one has a y, that one doesn't. When there is no common factor, you take the simplest common factor that you can always find, which is the number 1. You have to put a number there. You can't leave it blank. And since the leading coefficient is negative, my common factor is going to be -1. Now, divide the -1 into -3y, and it'll give you +3y. The -1 into the +2 will give you -2. This will indicate that you're on the right track when these two parentheses are the same. You put that 3y minus 2 first, and in your second parentheses, you put 2y minus 1. And there was no common factor, so this is our final answer. Okay. Want to show you one other thing that might pop up. You might encounter a problem that looks like this. Six x fourth y squared plus 18 x cubed y cubed minus 24 x squared 1/4. Okay, and I look at this, and of course, the first thing, if I want to factor, and these are all factoring problems, the first thing I want to do is I want to see if there's a common factor. Maybe that will make life look simpler. In any case, I always look for a common factor first. So looking at the coefficients, 6, 18, and 24, obviously 6 is a common factor. And it's a +6 because we're starting with a positive here. Then let's look at the x's. There's an x4, an x3, and x2. So there's an x term in each one, and the lowest x one I'm seeing is x squared. Now I look at the y's. There's a y squared, a y third, a y fourth. Again, every term has a y in it, and the lowest exponent is y squared. So my common monomial factor is 6x squared y squared. Okay, let's factor this out. So the 6 cancels into the 6, gone. X squared divides into x fourth. Remember, 4 minus 2 is 2. That gives me x squared. The y squared into the y squared cancels out. I'm not left with any y's there because it's really y to the 0, which is just the number 1. Okay, now we go to the next term. 6 into 18 is 3. X squared into x cubed. 3 minus 2 is 1, so that gives me x to the 1, or just plain x. Y squared into y cubed, that's 3 minus 2 again, the exponent is 1. And finally, we do the 6 into the negative 24 gives me negative 4. The x squared into the x squared cancel out. 2 minus 2 is 0, there's no x's left. Y squared into y fourth gives me y squared. And it turns out that the polynomial, the trinomial that I'm left with is x to the second plus 3xy minus 4y squared. Now don't stop just there. I want to see, this is a trinomial. Sometimes trinomials can be factored further. Can I simplify this? Can I factor this further? And one of the problems that arises here is that there are 2 letters. There's not just x's, there's x's and y's. So, and that makes it look very confusing. So here's what I'm going to do. I'm going to rewrite that trinomial without the y's. If I just write the x's, I'll get x squared plus 3x minus 4. For the interim, well, we're working on it. Ignore the y's. And factor this expression, x squared plus 3x minus 4. Well, it's just a regular trinomial. And my AC is 1 times negative 4, which is negative 4. And my B is positive 3. So I'm looking for numbers that multiply to negative 4. So one's going to be positive and one's going to be negative, because the only way we're going to get a negative answer is if one is positive and one is negative. And either it can be 4 and 1, or 1 and 4, or 2 and 2. Those are the only things that multiply to 4. And when I combine them, the first combination will give me a positive 4 with a negative 1, which gives me positive 3. So this is my, it's a 1, it's just a minus. So my correct combination here would be positive 4 and negative 1. Rewriting this gives me x squared plus 4x minus 1x minus 4. And of course, we do what we've done just before. Our common factor in the first group is x, so this becomes x times x plus 4. In my second group, the only common factor is the negative 1. So I put a negative 1 on the outside, and that gives me a positive x and a positive 4. So that in my parentheses, I get x plus 4 and x minus 1. Now notice I've left a space after the 4 and after the 1. Why? Because now I can go back to my original trinomial that had y's in it. All I have to do is put a y at the end of each parentheses. X plus 4y and x minus 1y, which we usually don't put the 1 in, we'll just write x minus y. So just make it simpler for yourself by ignoring your second variable, but at the end, just stick that second variable in at the end of each parentheses, next to the last number in each parentheses. Of course, don't forget that we originally had a 6x squared y squared as our, and this would be, this example, completely factored. Notice it wasn't enough just to take out the common factor. You had to see if you could factor the trinomial further. Okay, let's try another example. I'll give you one to try and then we'll go on to the next topic. Okay, here's an example. I'm going to give you a couple minutes to try. All right, I want to do something else. I want to do something that's similar to what we just did. See if you can factor this. 16a squared plus 40ab plus 25b squared. Okay, I'm going to give you a couple of minutes to try that out. Okay, I think we should try and work on this together. So first of all, we're dealing with a trinomial. It happens to have two variables. In this case, it's a and b, not x and y, but it doesn't matter. Okay, thank you. Somebody did finish it. It looks good. Okay, but the first thing we always want to look for is there a common factor. So between 16, 40, and 25, there's no number that goes into all of them. And this one has A's but no B's, and this has B's and no A's, so there's no common letter throughout either. So what we're going to do to make this look a little simpler is we're going to write it without the second variable. We're going to write it 16a squared plus 40a plus 25. And we'll stick in the b's at the end, but at least it's not so overpowering when we look at it. And again, we had no common factors, so we're going to use our AC method. Our AC is going to be 16 times 25. Now, this is something that you could use a calculator with. 16 times 25 is 400, and it's positive. And the B is 40, positive. First of all, since everything here is positive, I know my two numbers have to be positives. Because in order to get a positive product, either it's two pluses or two minuses, but the middle term being positive means everything is positive. So let's see if we can figure out what multiplies to 400, but when we add it, gives us 40. So, certainly we might have 40 times 10. That certainly multiplies to 400, but it adds to 50. It doesn't add to 40.
20 and 20?
What about 20 and 20? That sounds like a good choice. 20 and 20, when you multiply them, give you 400, and 20 plus 20 gives you 40. Thank you, that was perfect. So when the numbers are big, you really have to play with them. Again, if you have a calculator, you can do it really quickly. You just keep trying numbers and see which ones multiply to the right number and add to the number. So obviously we're going to have 20 and 20. So I'm going to write this as 16a squared plus 20a plus 20a plus 25. When the numbers are really big, it's probably makes sense to start with just dividing this number in half and see if that works. That would have been a good choice. Now, in my first group of 16a squared and 20a, first of all, between 16 and 24 is a common factor, and we have an a in both terms. So 4a into 16a squared is 4a, and 4a into 20a is positive 5. In my second group, I have a 20a and a 25. So between the 20 and the 25, my common factor is 5. So 5 into 28 is 4a, and 5 into 25 is 5. So that when I get my final answer, I get 4a plus 5. Remember, I'm leaving space in there for the missing letter. And the second parentheses is also 4a plus 5. Of course, now we're going to stick in our b's at the end. And this would be my final answer. If you notice, both parentheses are identical. These are not conjugate binomials. These are identical binomials. Not only do they have the same numbers and letters, they have the same sign. We could,
So
write it as,
The answer could it be 4a plus 5b squared?
yes, that's just what I was gonna write. You
Okay.
could, when the two parentheses are the same, you could write it as a binomial with a square on the outside. So the operation is the same that we've been doing all along, but if both parentheses turn out to be exactly the same, then we can, instead of writing both parentheses, it's not wrong to write it 4a plus 5b and 4a plus 5b, but the more efficient way to write it is 4a plus 5b with the parentheses and the square on the outside. And I would assume on a multiple choice test, this would be the answer they would give you as opposed to this answer. They want to give you both because they're both correct. It's just, this is a more elegant way of writing the answer. I think we're at the point where we have covered factoring quite thoroughly. We'll be doing factoring throughout the term. There are many different types of procedures in mathematics that require us to do factoring. What I'd like to do now, just as a start, is to talk about one very important topic that uses factoring, and that is something called solving quadratic equations. So that's our next topic. The type of equations that we have been solving until now are what we call linear equations. Linear equations are also called first degree equation. In other words, all the equations we've been doing, that we've been solving, didn't have any exponents. It was just 3x plus 7y minus 5x plus 20 equals 2x plus 1, for example. There were no x squares in it. We reviewed, actually, it was not even part of the time, we just do it. It was the very first thing we talked about was solving a linear equation, then we went into the inequalities. So we did linear equations. Now we want to talk about something that's called a quadratic equation. Another word for quadratic equation is second degree equations. In other words, you'll know you have a quadratic equation if you have an x squared or some other exponent in it. Sometimes it's even a higher exponent, but we're going to literally start with exponents where the exponent is 2. That is a quadratic equation, and that's what we're going to talk about solving. We're going to do this in stages. We're going to talk about it now, then we're going to leave the topic, and a little later in the term, we're going to talk about it again. We're going to talk in this chapter with solving for quadratic equations using factoring. So let me show you how this method works. I will take a quadratic equation. Let's say I have x squared minus 2x minus 24 equals 0. I know it's a quadratic equation simply because it's not just a plain x, there is an x squared. Whenever you have a quadratic equation, and I'm going to show you the process and then I'm going to explain why that process makes sense. Whenever you have a quadratic equation, again, you'll know it's a quadratic equation by seeing an x squared term. You'll see an x with an exponent. You are going to make sure that that equation is equal to 0. If it's not equal to 0, you're gonna have to get it equal to 0. We're lucky. This one already equals 0. But equaling 0 is not what makes it a quadratic equation. What makes it a quadratic equation is that because there's an x squared. What you do is after you have your equation equal to 0, you take the side that's not equal to 0 and you try and factor it. In this chapter, we're only going to be dealing with examples that can be factored. We'll talk about what happens if you can't factor later on in the term. But right now, we're going to be dealing with things that could be factored. Okay, now, how do I factor? Well, look at it. Now I go back to what I was just talking about. This happens to be a trinomial. And the first thing I look, is there a common factor? And there isn't. But with a trinomial, I'm going to want to use my AC method. And my AC in this case would be 1 times negative 24, which is negative 24. And my B is the negative 2. And I'm looking for two numbers that multiply to 24 to negative 24, which means one is going to have to be positive and one is going to have to be negative. And when I combine those two numbers, I'm going to get a negative 2. And well, let's think about it. It could be 24 and 12 and 2 is not going to give me 2. 8 and 3 is not going to give me 2. But 6 and 4, if I have a positive 6 and a negative 4, well, that'll give me a positive 2. So I will want a positive 4 and a negative 6. Everybody okay with that? Otherwise you just make a list of all the numbers or just take it on your calculator and just see 1 times 24 plus 1 and a negative 24 gives me negative 3. It doesn't work. Since this middle number is small, it must mean the numbers are close together. When the middle number is big, it means the numbers are further apart. So this will really give me x squared. Here's my negative 24, a positive 4x, and a negative 6x. And in the first group, I have a common factor of x, so this becomes x plus 4. And in my second group, I have a common factor of negative 6, and that will give me x plus 4. I'm doing this a little faster because I think you've seen so many of them. Negative 6 into negative 6x is x, negative 6 into negative 24 is positive 4. So this gives me x plus 4 and x minus 6 as my factoring, and that's equal to 0 going back to the other side. Now here is where it's different than what we did before. When we were factoring, we would stop right here. We would stop at the x plus 4 and the x minus 6. The rule would be factor. But here we're being asked to solve. When we're looking to solve an equation, it's not enough to make it simpler, which we do when we factor, but actually going on to finding what x equals. And here's where we use a little bit of reasoning. Let's call x plus 4 some number a, and x minus 6 some other number b. There are two numbers. If x is 22, then x plus 4 would be 22 plus 4, which is 26. And b would be 22 minus 6, which would be 16. In other words, these are not the same number because you're taking some number which we don't know. In one case, you're adding 4 to it, in another case, you're subtracting 6 from it. But they're two numbers. Once we know what x is, we'll know what those two numbers are. So what do we know about these two numbers? We're multiplying the a times the b, and the answer we're getting is 0. Now, 0 is a very special number. When you multiply two numbers and you get 0 as an answer, it must mean that one of the numbers you multiplied had to have been 0. You'll never be able to multiply two numbers and get 0 unless one of the numbers you were using to multiply by was 0. Now, that's not true of any other number. Like if I get an answer that's going to be 12, it could be 3 and 4, it could be 12 and 1, it could even be a half and 24. There are millions of combinations. But if you get something times something equaling 0, it must mean that either the A equals 0 or the B. They don't both have to be equal to 0, but one of them has to be equal to 0. Either the A has to be equal to 0 or the B is equal to 0. Well, that means either the x plus 4 equals 0 or the x minus 6 equals 0, which tells us what our next step is. Remember what I told you, when it's a quadratic equation, you have to get it equal to 0. You then factor it, and then you separate each factor. One factor is x plus 4, one factor is x minus 6. You separately set them equal to 0 because one of them for sure has to be equal to 0. Now, if x plus 4 equals 0, I can solve that by bringing the 4 to the other side, and that'll give me x equals -4 as one possible answer. And over here, when you have x minus 6 equals 0, you want to get the 6 to the other side, and you get x equals +6. And it turns out when you're solving a quadratic equation, you're going to get, in most cases, two answers. In this case, the two answers that we got were -4 and +6. And if you do get two answers, then you must give both answers as your solution. Notice I didn't stop at the factoring part. How did I know to go further? Because it said solve. The word solve is in it, and then there was an equal sign in the example, which meant it was an equation. Okay, let's try another one like this. Suppose I gave you this equation, 3x squared plus x equals 10. And I want to solve this equation. Okay, it's definitely an equation because I see an equal sign in it. And I know it's a quadratic equation because I see an exponent of 2. I have an exponent, and it means it's a quadratic equation. It's not a linear equation. Remember, we have to make that decision right at the beginning because the approach is so different. Since it's a quadratic equation, I have to get it equal to 0. If it's not equal to 0, I have to get it equal to 0. So usually I look where the x squared term is, and I want to leave that positive. I want to leave it here. So I want to get rid of the 10 that's over here. So I'm going to subtract 10 from both sides, which will give me 3x squared plus x minus 10 equaling, now this is 0 because I got rid of it. Notice my terms are in what we call descending order. The x squared term, the x, and the number. I can rearrange my terms any way I want them. So that's the way I want them because I want to be able to factor. It is a quadratic equation. I want to solve it by factoring. And again, I'm just going to look at the trinomial. And it's a trinomial. There is no common factor, so I'm going to use the AC method. The AC is going to be 3 times negative 10, which is negative 30. And the B, well, what's the number in front of the X? It's a 1, it's a plus 1. So we're looking for two numbers that multiply to negative 30, which means one's going to be positive and one's going to be negative. But when I combine them, it's only going to give me 1. Now, since the number that it combines to is very small, it must mean the two numbers that we're dealing with are close together. And the numbers that are closest together when you multiply to 30 are obviously 5 and 6. So let's see what happens when I try a positive 5 and a negative 6. When I combine, obviously it multiplies to negative 30, but when I add positive 5 and negative 6, I get negative 1. It's the right number, wrong sign. So I'm going to switch this around. I'm going to make this the positive 6 and the 5 the negative. And that's going to be the correct combination that we want. So rewriting this, we're going to rewrite this as 3x squared plus 6x minus 5x minus 10. I'm going to leave equal 0, we're going to leave that till the end. We just want to factor now. In my first group, I have a common factor of 3x, so that becomes x plus 2. In my second group, I have a common factor of negative 5, because I see it starting with a negative, and that's going to give me x, and negative 5 into negative 10 is also positive 2. So this will give me x plus 2 in one parentheses, and in my second parentheses, I'll get 3x minus 5. Okay, so I've done the factoring. I'm putting back the equal to 0. Remember, with a quadratic equation, after you're finished factoring, you go the next step. You take each parentheses, each factor, and set it separately equal to 0. And solve each of these equations. So x plus 2 equals 0. I'll just bring the 2 to the other side. And one answer I'll get is x equals negative 2. The other equation, I'll bring the 5 to the other side. And that'll give me 3x equals 5. And then, of course, I'm not finished because I want to get what x is, so I'll divide both sides by 3. So my second answer is 5/3. So my solution, again, I have two answers, negative 2 and positive 5/3. And there's nothing wrong with having a fraction as an answer or a negative number as an answer. Quadratic equations, sometimes the two answers come out to be the same. That's why I say that in most cases you get two answers, because sometimes you get two answers, but they're the same number, so you really wouldn't consider it two answers. And that's how we solve a quadratic equation. Of course, we couldn't do this if we didn't know how to factor. Okay, so I'm going to end here. It's Thursday, so I won't see you until next Tuesday. Have a nice weekend. Don't forget to look on Delta Math. I will probably be posting a new homework on Delta Math by tonight. That'll be helpful in what we're doing here. It'll be on factoring and quadratic equations. We're almost completed with everything we have to know for the midterm. I'm going to be completing the midterm material by next Tuesday. And again, we're going to be talking about when the midterm will be and when you'll have the practice midterm test on Blackboard. But as of now, there is a review sheet in your weekly folder. Look for your review sheet in your weekly folder to get an idea of the type of questions you are responsible for this course. Any questions? If not, I'm going to end right now. Have a great weekend. And
You too, Professor.
Have a great weekend, Professor.
And make sure you keep up to, you're up to par with all your work, because we're getting to crunch time. We're almost at the halfway mark in the term. We're approaching the midterm. As I said, right after the midterm, I'm going to be sending you out a mark for each, I'll work it out for each person. I do this at least 2 times during the term. I figure out where a person is standing at that point. Of course, I do it at the end of the term also to give you your final grade, but I want to give you an idea of where you are by right after midterm, so you really know if you what your standing is. Okay, have a great weekend. Bye.
Where will the recordings for the class be?
You go on Blackboard, and it says class recordings. There's on the Blackboard, one of the titles on the side is class recordings, and they're all there.
All right. Yeah.
And they're
'Cause
all
my internet cut out in between class and I missed a little bit.
they're all labeled by the date, by which class it was, and also usually has a topic included, so you can see exactly which is which. Okay?
All right.